Hi everyone. So in this video, we'll talk about Project 2 linked list, stacks, queues, and STL. We will be given two code, one in square clause and another in list clause. For square clause, we need to change the type of site data member from double to int. And for list clause, we need to modify it from doubly linked list to singly linked list. We also need to add these two methods. After that, we'll be doing the following instructions to perform those operations. Now let's look through the given code more detailedly. First, we have our function for generating random numbers. Then we have our list clause. This is our struct data members. And we have constant iterator clause and our iterator clause, which we will be rewrite operators to our defined one in those two clauses. Then we're gonna have some functions and some basic operations like push front, push back, pop front, pop back, which we'll be using it in our main function. Lastly, we have our square clause, which contains constructor and some get functions and print the contents. And here, it also shows you how to use the square clause in the main function. As we mentioned before, we need to modify our list clause from doubly to singly. So let's look through the figure of doubly linked list. We can see there are two links in each node pointing in opposite directions. And for singly linked list, there are only one links to each node. So this is my modification. As what we can see, I delete the previous node because unlike doubly linked list, singly linked list only goes through one direction, so we cannot access to the previous. Since we did not define our previous node in the struct data members, we need to modify all the operations that involve in previous node. So here's one way that you can define the previous node, which you initialize the previous node to head, and as you go on to the list, the previous node's next will be the current, so you will find your previous node. Lastly, since we need to delete all squares for later, I add a function for deleting the all squares, which walk through the list and delete all the all squares we have. So in order to check our list clause and square clause, we will need to test to see if them works or not. So here is the procedural code for this test case. We're gonna create for empty list, and we're gonna generate the interject A, and we're gonna construct a square object X based on this K, and we're gonna push front for L1 and push back for L2, and we need to check if L3 contains this object X or not. And if it does not contain this X, we're gonna just insert this X into a random position P. Next, we need to check if L3 contains 5 square object or not. If it does, we're gonna just make L4 equal to L3 and pop from the pop back of L4. Lastly, we just need to check if L1 contains 5 square objects or not. If the answer is yes, we just copy L1 to L5 and delete all outside squares. We can use the function that we defined in the list clause. And then we're gonna clear L5, and we will display L1 to L4 and gonna clear them and print them again to make sure we did clear the list. So here is the output for my test case. Notice in here we have inserted 5 square objects, so L4 will copy L3 but pop off 46 and 60, and for L5 it will copy L1 and remove all outside square, which is 21, and left with even size squares. And here, as what we see, we have inserted 20 square objects. So we finish what we need to do, and then we display all of them, and then we need to clear them. So see, here's empty now. No. Okay, so that's all for project 2, and thank you for watching.